Imagine taking a massive sledgehammer and swinging it as hard as you can against a solid anvil. Now, imagine doing that thousands of times a day, every single day, for years. That violent, bone-rattling shockwave. That is exactly what a bulldozer experiences when it rams its steel blade into solid rock. By the mid-1970s, the mining industry had a massive problem. They needed bigger bulldozers to rip harder earth and push heavier loads. But physics was standing in their way. Every time they built a bigger, heavier machine, the sheer force of hitting unyielding rock was shattering the internal gears. The dozers were literally tearing themselves apart from the inside out. The industry thought they had reached the absolute limit of bulldozer design. And then, in 1977, Caterpillar rolled a machine out of the factory doors that made everyone stop and stare. It didn't look like any dozer that had ever existed. Its tracks weren't flat. They formed a massive, bizarre triangle. The primary drive gear had been lifted completely out of the mud and suspended high in the air. Competitors laughed. They called it top-heavy. They said it was overly complicated. They swore it would be a colossal failure that would bankrupt Caterpillar. Instead, it completely broke the industry, buried the competition, and changed the DNA of heavy earth-moving forever. This is the story of the machine that was supposed to fail, the bulldozer that reinvented the wheel by moving the sprocket. This is the legendary Caterpillar D10. To understand the genius of the Caterpillar D10, you have to understand the fatal flaw of every bulldozer built before it. Since the early 1900s, the design of a crawler tractor was pretty much set in stone. You had an engine in the front, a transmission in the back, and a steel track wrapped around an oval frame. At the very back corner of that track, sitting right down in the dirt, was the sprocket, the massive toothed wheel that actually turns the track and pushes the machine forward. For decades, this flat track design worked fine. But in the 1970s, the mining boom demanded machines that could rip solid rock right out of the ground. When a bulldozer is dragging a massive steel claw through solid earth, the forces are catastrophic. If the ripper hook suddenly hits an immovable boulder underground, all that forward momentum has to go somewhere. In a traditional flat-track dozer, that violent shockwave traveled straight from the ground, through the track frame, directly into the final drive gears, the most expensive and critical part of the transmission. Because the drive sprocket was the only thing holding the back of the machine up, it was taking the entire weight of the tractor, plus the violent impact of the rock. It was a recipe for disaster. Final drives were snapping. Bearings were shattering. The machines were spending more time in the repair shop than in the dirt. Caterpillar, the undisputed king of earth-moving, knew that simply making the gears thicker wasn't going to work anymore. The flat-track design had reached its absolute physical limit. If they wanted to build a bigger machine, they had to throw away 70 years of engineering history and start from absolute scratch. Deep inside Caterpillar's research and development facility in Peoria, Illinois, a top-secret team of engineers locked themselves in a room. Their mission was simple: build a machine capable of producing over 700 horsepower and figure out a way to keep it from destroying itself. They realized that the final drive gears were the Achilles heel. As long as the drive sprocket was sitting in the mud, acting as a load-bearing wheel, it was doomed. So, an engineer asked a crazy question. What if we just move the sprocket? What if we take the final drive, lift it high up into the air, and completely isolate it from the ground? It was a radical concept. By raising the drive sprocket above the track roller frame, the track took on a triangular shape. This design did two incredible things. First, it completely removed the final drives from the shockwaves of the ground. The sprocket was no longer supporting the massive weight of the machine. Its only job now was to turn the track. Second, it pulled the final drives out of the abrasive, grinding mud and rock of the mine floor, vastly extending their lifespan. But this elevated sprocket, or high drive design, created a new set of nightmares. A triangular track meant a taller machine. A taller machine meant a higher center of gravity. How do you stop a 90-ton bulldozer from tipping over on a steep mountain grade? The engineers solved this by placing the massively heavy engine, the transmission, and the main frame extremely low between the tracks. The sprocket was high, but the heavy iron was lower than ever. They were designing a mechanical masterpiece. But it was a massive, expensive gamble. If this triangular design failed in the dirt, Caterpillar's reputation would take a hit they might never recover from. When the Caterpillar D10 was finally introduced to the world in September 1977, it was a monster that defied comprehension. Standing over 15 feet tall and weighing a staggering 190,000 pounds, it was by far the largest, most powerful crawler tractor ever built. Underneath the massive yellow hood was a Cat D348, a twin turbocharged 1,786 cubic inch V12 diesel engine. This was the same roaring power plant used in their massive off-highway trucks, and in the D10, it was tuned to produce a relentless 700 flywheel horsepower. But the engine wasn't the star of the show. The real magic was happening down below. Because the drive sprocket was elevated, the entire undercarriage could be redesigned. Traditional dozers had rigid track frames, meaning if you drove over a rock, the entire machine tilted, lifting the track off the ground and losing traction. But the D10 introduced a fully suspended, resilient undercarriage. The track rollers were mounted on pivoting bogies. This meant the track could actually flex and wrap itself around rocks and uneven terrain, keeping maximum steel on the ground at all times. It was like giving a 90-ton tank the suspension of a luxury car. Operators who were used to getting their spines compacted in traditional dozers were suddenly gliding over brutal terrain. And then there was the maintenance. In the mining industry, time is blood. On a traditional dozer, if you broke a final drive, mechanics had to break the track, remove the track frames, and spend days tearing the machine apart just to reach the broken gears. The high-drive D10 changed the game. Because the transmission and final drives were elevated and modular, a mechanic could simply walk up to the side of the machine, unbolt the final drive module, pull it out, slide a new one in, and have the dozer back to work in hours, not days. You didn't even have to take the tracks off. It was an absolute engineering triumph, but not everyone saw it that way. When competitors like Komatsu and Fiat Alice saw the D10, they didn't panic, they gloated. To the traditionalists, the high drive looked like a desperate, over-engineered mess. The trade magazines published skeptical articles. Competitors printed brochures actively mocking the triangular design, claiming the tracks would wear out too fast, the machine would be unstable, and the complexity would be a nightmare to maintain. They told mining companies, "Stick with what you know. Flat tracks are proven. The D10 is a gimmick." But then, the D10 actually hit the dirt. Caterpillar sent the first production models into the most brutal copper mines, coal pits, and limestone quarries they could find, and the results were absolutely terrifying for the competition. When a flat-track dozer hit solid rock, the operator had to back off or risk destroying the machine. When the D10 hit solid rock, the elevated sprocket just kept turning. The suspended undercarriage gripped the earth, the twin-turbo V12 screamed, and the rock shattered. The D10 wasn't just ripping rock, It was outproducing every other machine on the market by massive margins. It was doing the work of two traditional dozers. The critics were silenced. The operators refused to drive anything else. And the mining executives, looking at the massive increase in production and the dramatic drop in transmission failures, started writing blank checks to Caterpillar. The competitors who had laughed at the high drive suddenly found themselves in a state of absolute panic. They had to go back to the drawing board, knowing they were now a decade behind Caterpillar's engineering. The original D10 ran from 1977 to 1986, moving millions of tons of earth, and proving that taking a massive risk can change the world. It wasn't just a successful product, it was a paradigm shift. The elevated sprocket design was so vastly superior that Caterpillar eventually adapted it to almost their entire line of crawler tractors, from the smaller D4 all the way up to the colossal modern D11. Today, if you look at any massive Caterpillar dozer pushing earth anywhere on the planet, you will see that unmistakable triangular track. The critics said it was a mistake. They said the flat track was the only way to build a bulldozer. But the engineers at Caterpillar proved that sometimes, to move a mountain, you have to be willing to reinvent the machine that moves it. The D10 didn't just rip rock, it ripped up the rule book. It is a testament to an era when American heavy engineering looked an impossible problem in the eye and engineered a way around it. Thank you for watching U.S. Mining Machines. If you respect the iron and the history of these mechanical legends, hit that subscribe button. Next time, we are diving deep into the massive engines that powered these beasts. Until then, keep digging.